Hello everyone, welcome back to my YouTube channel. Myself, Kushi.D from Sri Venkateswara College of Engineering. My USN is 1VE20IS014. Today's topic will be solar flat plate collectors. Let's see the introduction part of the solar flat plate collectors. Solar thermal collector. A solar thermal collectors are special kind of heat exchangers that transform solar radiation energy to internal energy of the transport medium. The major component of any solar system is the solar collector. Solar collectors. Collectors is a device which absorbs the incoming solar radiation, converts it into heat and transfers this heat to a fluid, usually air, water or oil, flowing through the collector. The solar energy thus collected is carried from the circulating fluid either directly to the hot water or space conditioning equipment, or to a thermal energy storage tank from which can be drawn for use at night and or cloudy days. Types of solar thermal collectors. Solar collectors are either non-concentrating or concentrating. So we have two types of solar thermal collectors, that is non-concentrating or concentrating. So in the non-concentrating type, the collector area, that is the area that intercepts the solar radiation, is the same as the absorber area, the area absorbing the radiation. In these type, the whole solar panel absorbs light. Concentrating collectors have a bigger interceptor than absorber. For domestic or industrial water heating and spacing heating purposes, the solar thermal collectors are classified as flat plate solar collectors and evacuated tube solar collectors. Flat plate collectors. So in the flat plate collectors developed by Hotel and Villiers in the 1950s are the most common type of solar collector, which are widely used for domestic household water heating and space heating where the demand temperature is low. Flat plate collector is basically a black surface that is placed at a convenient path of a sun. Evacuated tube solar thermal collector. ETCs are built to reduce convective and heat conduction loss, that is, vacuum is a heat insulator. Each evacuated tube consists of two glass tubes. The outer tube is made up of extremely strong transparent glass and that is able to withstand changing climatic condition. The inner tube is also made of glass but coated with a special selective coating which features excellent solar heat absorption and minimal heat reflection properties. The air is evacuated from the space between the two glass tubes form a vacuum. So this is the picture which actually speaks about the previous slide. It has a header pipe, then manifold, heat transfer fin, evacuated tube, heat pipe, mounting frame. Components of solar flat plate collectors. They consist of dark flat plate absorber, a transparent cover that reduces heat losses and glazing, a heat transport fluid, that is air, antifreeze or water to remove heat from the absorber, a heat insulating backing, flow passage and enclosure. So this is the picture which consists of header, razors, glazing, absorber plate, insulation and black plate. Next, let us see what is absorber plate. It is usually made of copper, steel and plastic. The surface is covered with flat black material of high absorptance. If copper or steel is used to this, it is possible to apply a selective coating that maximizes the absorptance of solar energy and minimizes the radiations emitted by the plate. Flow passages. The flow passages conduct the working fluid through the collector. If the working fluid is a liquid, the flow passage is usually a tube that is attached to or is a part of absorber plate. If the working fluid is air, the flow of passage should be below the absorber plate to minimize heat losses. Next, we have cover plate. To reduce the convective and radiative heat losses from the absorber, one or two transparent covers are generally placed above the absorber plate. They usually be made from glass or plastic. Next we have is insulation. These are some materials such as fiberglass and they are placed at the back and sides of the collector to reduce heat losses. So this insulation is used to reduce the heat losses. Next we have is enclosure. A box that the collector is enclosed in holds the components together, protect them from weather, facilitates installation of the collector on a roof or appropriate frame. So this is the picture, a typical diagram of flat plate solar thermal connector. Next we have absorber plate and flow passages. Copper, which has high conductivity, is corrosion resistant, is the material for an absorber plate, but because of copper is expensive, steel is also widely used. For copper plate 0.05 centimeter thickness with 1.25 centimeter tubes spaced 15 centimeter apart is good thermal contact with copper. The fin efficiency is better than 95%. The surface of the absorber plate determines how much of the incident solar radiation is absorbed and how much is emitted at a given temperature. Flat black paint, which is widely used as a coating, has an absorbance of about 95% for incident shortwave solar radiation. It is durable and easy to apply. Next we have, here's a table about matters that absorber plate may be made from. So it can be made from black silicon paint, then black copper over copper. Then we have black chrome over nickel. So this is the figure. We can see absorber plate and flow passages. So we have cool fluid in, warm fluid out. Sun heats fluid as it throws through tubes. Next is cover plates. So a cover plate for a collector should have a high transmittance for a solar radiation and should not deteriorate with time. The material most commonly used is glass. A 0.32 centimeter thick sheet of window glass, iron content 0.12%, transmits 85% of solar energy at normal incidence, and all glass is practically opaque to long wavelength radiation emitted by the absorber plate. Some plastic materials can be used for collector glazing. They are cheaper and lighter than glass, and because they can be used in very thin sheets, they often have higher transmittance. However, they are not as durable as glass and they often degrade with exposure to ultraviolet radiations or high temperatures. So here's a table about matters that covers plate may be made up of. So it can be Like how it can be tested is by solar transmission, then maximum operating temperature in degrees Celsius, thermal expansion coefficient, thickness length of life and year. Here is the figure. We can see cover part, that is cross section of cover part of a flat plate collector. So we have short wavelength radiation from sun, long wavelength radiation re-emitted by absorber plate, and this is glazing. Next, enclosure or insulation. The collector enclosure is usually made from steel, aluminium or fiberglass. In order to prevent heat from escaping through the back of the collector, a layer of insulation is placed behind the absorber plate. So these are the characteristics of insulation material. So this is the table where it consider material will be present, that is fiberglass with organic binder. So for all the four parts we'll be using the fiberglass with organic binder, where the ratio will be differing, that is we use 11, 16, 24 and 48, and the respective values also will be differing or changing. So this is the figure. We can see insulation part, that is the cross section. This is the cross section of a collector. So where the insulation part of flat plate collector is done. Working principle of flat plate collector. In flat plate collector, sunlight passes through the glazing and strikes the absorber plate, which heats up, changing solar energy into heat energy. Thus the heat is transferred to the fluid, liquid, that is water or oil, or gas, that is nothing but air, passing through the pipes attached to the absorber plate by means of convective heat transfer. Absorber plates are commonly painted with selective coating which absorb and retain heat better than ordinary black paint. Absorber plates are usually made of metal, typically copper or aluminium. Because the metal is good heat conductor, copper is more expensive, but it is better conductor and less prone to corrosion than aluminium. In location with average available solar energy, flat plate collectors are sized with approximately 1/2 to 1 square foot per gallon of one day's hot water use. So you could see this image depicting it. So this is a flat plate collector, solar air heater. So you have ambient air, we have perforated absorber, heated air coming out, and plenum. Next we have collector performance. So when we have designed everything, we have to check its performance as well. So we will be seeing about collector performance. The thermal performance of a collector can be calculated from the first law of energy balance. According to the first law of thermodynamics, for a simple flat plate collector, an instantaneous steady state energy balance is useful energy gain, that is QU, is equal to energy absorbed by the collector minus heat loss to the surroundings. So this is the law of thermodynamics used for measuring the collector's performance. Next, an absorbed energy is equal to AC FRS. Lost energy equal to AC FRUL whole of Ti minus Ta, which is nothing but all are like product, and this will be multiplied with Ti minus Ta, where AC is nothing but collector area M2, FR heat removal factor unitless, S is equal to absorbed solar radiation, that is joules per meter square. UL is nothing but heat transfer loss coefficient, joules per meter square degree Celsius. Ti, the mean absorber plate temperature, that is degree Celsius. TA is equal to the ambient temperature degree Celsius. So QU is equal to AC into FR into S minus AC into FR into UL whole of Ti minus TA. So this is the equation. Next, we have above equation is extremely useful equation and applies to essentially all flat plate collectors. To improve the performance of solar collectors, it is necessary to either to reduce the overall energy loss coefficient or reduce area from which energy is lost. That is, the maximum possible useful energy gain, that is heat transfer, in a solar collector occur when the whole collector is at the inlet fluid temperature, that is heat losses to the surrounding are then at a minimum. Collector efficiency. The basic method of measuring collector performance is to expose the operating collectors to solar radiation and measure the fluid inlet and outlet temperature and the fluid flow rate. The useful gain is Qu equal to m dash Cp into T naught minus Ti. Next, the above equation describes thermal performance of a collector operating under steady conditions can be rewritten as Qu equal to AC into Fr whole of Gt into T alpha minus UL into whole of Ti minus T alpha. So this is the final equation, which is also be written as this. Next, applications of flat plate collectors. So in the applications of the flat plate collectors, we have both domestic application and commercial applications. Domestic application, flat plate collectors mainly used in residential buildings. Then for instance, a family of 4 members consumes on an average 100 liters of hot water a day at 60 degrees Celsius. Hot waters of 100 liter capacity at 60 degrees Celsius approximate can be delivered by a single collector system of 2 meter square area. Then we have solar water heating systems are generally provided with auxiliary backup in the insulated hot storage tank for rainy and heavy overcast cloudy days. So this is the image of it, picture. Next we have commercial applications, where commercial application include land road maps, car washes, military laundry facilities and eating establishments. And unglazed liquid collectors are commonly used for heating water from swimming pool, because these collectors need not withstand high temperatures. They can use less expensive materials such as plastics and rubbers. They also do not require freezing proof, because swimming pools are generally used in only warm weather or can be drained easily during cold weather. So this is it. So let's see what is the conclusion. The flat plate collectors, which are used for water heating, are long lasting and also in long term, which are cheaper than other water heating systems. However, they require large area if high energy output is requirement. Also, solar energy is free if we do not include the initial maintenance. Finally, besides these, we should remember by using solar energy we can protect nature. Thank you everyone for watching my video. Please do like, share, comment and subscribe. Thank you.